Welcome to Secret Squared.
I'm Cassie Secret.
I'm Megan Secrets.
And this is Daniel, our dog who decided to join the video today.
We're going to continue our series on exponent rules, and we're going to cover the zero exponent rule today.
Let's dive in.
So we're going to start with the zero exponent rule, and we're going to use that whenever we have an exponent of zero pop up.
I love this rule because it sounds exactly like what it means.
Unlike maybe like the power or the product rule, this one is a lot more straightforward.
Now, what's really important to know when we're talking about zero exponents is what does it actually equal when you have something to the power of zero?
To see what this actually equals, we're going to use a little bit of the quotient rule to see an example where the power of zero does pop up.
And it's actually going to help us really understand what it equals. Now, our example that we're going to do, and in this case, we're not going to use any variables, we're going to use numbers because it's going to be a lot clearer to see. So we're going to do 5 squared, instead of doing like x squared or something, 5 squared, and we're going to divide that by 5 squared. Now,
And since we're using the quotient rule, we have, or the fraction, we're dividing something, we have the same bases, they're both 5s instead of a variable. We're going to subtract the exponents. We'll do top exponent minus the bottom exponent. So really, we end up with 2 minus the 2. We get 5 to the 0, where that has that 0 exponent.
Now, when we get here, we're like, okay, but we still don't know what something to the power of 0 equals. But because we're actually working with numbers here, let's write it out instead of dealing with these exponents. So another way we could have done it is 5 squared, that's just 25. So you have 25 over 25. So we just took our fraction, and I just went ahead and we rewrote it using numbers instead.
And then we end up with 25 divided by 25, and that's really just 1. And the answer 5 to the 0 is actually the same as the answer as 1.
So this is actually a really easy way of showing that anything to the power of 0 is going to end up equaling 1. Now, we're going to end up,
so for our zero exponent rule, we're going to have that anything to 0 power. In this case, we're putting an x. It just means any base. Maybe it's a variable, maybe it's a number. Anything to the 0 power is just going to equal 1. So for our first example, we're going to have a few different terms multiplied together, but one thing to know is the zero exponent rule, a lot of the times you're going to use this rule with other rules, so it's not necessarily going to be where the question is asking you, what's like 5 to the 0? A lot of the times it might be something like this, where we don't really see the zero exponent, but it will show up somewhere along the way.
So first, it's important to identify what other rules we might be using. Now, since we're multiplying those terms, that multiplication is telling us that we're going to end up using our product rule. So we'll start with there and then see if a zero exponent shows up.
So for product rule, we are looking for all of the same bases. So for instance, we have, here's an x term, here's another x term, and there's a last x term. We are really looking at the exponents, and we are adding them all together. If we're using product rule, or if we're multiplying those terms together, which we are. So we end up with x, and we have exponent of 3, exponent of negative 2, exponent of a negative 1. 3 minus 2 gives you 1. 1 minus another 1 gives you 0. So we do have that 0 exponent pop up.
But again, just from looking at the problem in the beginning, you wouldn't see it, but it is going to show up later. Now, doing the same thing, but with our y, looking for those same bases, or in this case, the same variable, I have a y squared, a y to the power of 4, and on the end, I have a y where you don't see an exponent. Just a reminder, if you don't see that exponent, it's an exponent of 1. So take all of those exponents, 2 plus 4, 6, plus 1 is going to get you y to the power of 7. And then at this point, we can't combine anything any further because x and y are separate, are different bases, but x to the 0 is something to the 0 power. That is the same thing as saying it's equal to 1. So this is where we're going to be using that 0. So really have a 1 times that y to the 7th. So we still have that same terms, we're just now rewriting it to make it as simple as possible. And then 1 times anything is really just itself. So we end up with y to the 7th as our final answer. So for our next example, when we look at it, we already see that 0 exponent pop up, so we know we're going to have to deal with it somewhere. But we also have those parentheses and a bigger exponent outside, which reminds us that we're going to have to use the power rule. So in this case, for the power rule, what we have to do is we look at all of the different bases on the inside, or that are being raised to extra exponents, and we're going to have to multiply all of the exponents on the inside by that exponent on the outside. Reminder, there is no exponent for the c, which really means it's just 1 there. So now, doing our rule, we are going to go letter by letter. So starting with a, take the exponent of 0, multiply it by 2. Now 0 times 2 is just going to be 0, so we keep a to the power of 0. Now for the next one, for our b, take the exponent of 2, multiply with the exponent on the outside, so that will become b to the power of 4. And then for our last letter, we have that c to the first, and then we have to do that 1 times the 2, so we actually end up with c squared. Now, once you get here, we still have that 0, and don't mind our dog Daniel, he just wanted to pop in and say a quick hello. There is that a to the 0 right here, and anything to the 0 power, since that is just 1, we actually are able to rewrite this just like we did with the one before, as 1 times that b to the fourth and the c squared. And reminder, that 1 really just came from the yellow term, that a to the 0, because as our 0 exponent rule is telling us, anything to the power of 0 is the same as 1. And then at the end, we have 1 times b to some power and c to some power. We can't do any more combining or simplifying because b and c are separate variables. So our final answer for this one is going to be b to the fourth, c squared. Now, just a quick note, technically you would not be wrong if you were to stop here. That 1 in front, you can choose to write it or not. Also, depending on your teacher, some people might be okay with you even leaving a to the 0. However, for our case, we would like to simplify it as much as we can, so that's going to be our final answer. And another way you could have actually done this problem is, let's say at the very beginning, you're like, hey, I have something to the 0 power. I want to use the 0 exponent rule at the very beginning. You actually totally could have. You could have started by saying, hey, a to the 0 is just 1. And then we still have the b squared, and then we still have the c to the first. All that to the second power. And then you could have done the same thing where you use the power rule, take that exponent, multiply out to the exponents of the other terms inside. And if you did that, you'd actually get the exact same answer. So it's really just up to you. I will say though, if you're still kind of not feeling super confident in these new rules that you're learning, it tends to be helpful to just deal with the 0 exponent at the end. However, either way is going to work and it's going to get you the exact same answer. For our last example, our dog Daniel decided to join us, so don't mind him if he pops in and out of frame. For this example, instead of using power or the product rule, we're going to use the quotient rule where we have a little of that division. And again, use quotient rule whenever you see that you have that fraction. There is something with a 0 power exponent right there. We're just going to wait on that, and we're just going to go chunk by chunk, deal with the x's, the y's, and the z's using the quotient rule. You totally could look at this and say, hey, z to the 0 is just 1 and swap that out right now. It'll give you the same answer, and honestly, the steps will be pretty similar. But just for now, we want to make sure that you're getting really familiar with the rules. So starting with the x's, we have an x squared divided by an x squared. So we're going to subtract the exponents. 2 minus 2 gives you a 0. So we end up with an x to the 0. So there's our 0, one of our 0 exponents. For our next term, we have the y's. We have a y to the third and a y to the fourth. We always do the top exponent minus the bottom exponent. In this case, that 3 minus 4 gives you a -1. And even though this is negative, we are writing this on the top of the fraction. Whenever we do that top exponent minus the bottom exponent, we always write the exponent on top. Now, later on, we're going to end up moving it to get rid of the negative exponent, but that'll be at the very end. And then for our last letter, let's do our z's. We have z to the 6 on top and z to the 0 on bottom. Remember, quotient rule, do the top exponent minus the bottom. That gets you z to the power of 6. Now, once you get here, we want to simplify everything as much as we can. Now, what that's going to include, I have, first of all, something to the power of 0. We know anything to the power of 0 is 1, so I'm just going to go ahead and swap that out. So x to the 0 is 1, and then just for now, I'm going to rewrite the rest of it the exact same. So now we've dealt with that yellow term, we made that x to 0, 1. The blue term, that z to the 6, is fine. It has a positive exponent. The main thing to simplify is that green term, the y to the -1. And again, if you're still feeling a little unfamiliar with negative exponents, we have a video on here that we definitely recommend you check out. So to deal with that negative exponent, reminder, all that really means is that anything that has a negative exponent, it's now going to shift to the bottom or to the other part of the fraction. In this case, we're starting on the top of the fraction, so it's going to move to the bottom. Now, if it's kind of confusing to you that this is the top of the fraction, just a quick reminder that anything can be written as a fraction if you make it over 1. So just to make it a little easier to see, I added that. So that y is going to move to the bottom of the fraction, and now the negative exponent has turned into a positive 1. because again, that's the way that you deal with rewriting those negative
And
exponents.
we count a positive exponent as the simplest it could be. We really don't want to have to end with those negative exponents, which is why we rewrote it.
Exactly.
And then we still have that z to the 6 stays on top of the fraction because it doesn't have a negative exponent, so it's going to stay.
Now, for the one that was in front, I could put 1 times that on the front. You would still be correct. However, I like not writing it. It just makes my answer look a little bit simpler. So that's going to be how I'm going to leave it. Thanks
Thanks
for
for
watching.
watching.
If you enjoyed this video, please like and subscribe.
If you have any other topics you want us to cover in later videos, leave them in the comments below.
We'll
We'll
see
see you
you
next
next
time.
time.